Hello. In this video, we will be doing examples with combinations and permutations. So a permutation is an ordering of distinct objects. If we select our different objects from a set of n objects and arrange them in order, this is called a permutation. So in a permutation, order matters, or order is important. On the other hand, if we choose our objects from a set of n objects, we say that we are forming a combination of n objects taken r at a time. And we have a notation for both. So one example of permutations is license plates. So if the characters in the license plate are in different order, then we have different license plates. And an example of combinations is playing the lottery. As long as you have the winning set of numbers, you have the winning combination or the winning set, regardless of the order in which you selected the numbers. So that's the difference in one the order is important and the other one is not. Now, when doing word problems, you must determine from the context whether the order matters or doesn't. Here's the first example about scheduling interviews for a musical. Producers wish to interview 6 actors on 6 different days to replace the actor who played the Phantom in Broadway's longest running play, The Phantom of the Opera. So we want to find the number of ways in which the producers can schedule the interviews. And this is going to involve permutations because the order is determined by day. So we are going to use permutations. So we are going to draw a slot diagram. Let's say they are going to interview 6 actors in different ways. And we have day 1, day 2, day 3, day 4, 5, and 6. And we can count the number of ways with a slot diagram. So if they have 6 actors on the first day, they can interview 6 actors. Once they interview the first actor, they have 5 on the second day, 4 on the third day, then 3, then 2, then 1. So this happened to be 6 factorial. Really what we have is permutations of 6 objects taken 6 at a time. So according to the formula, this is 6. This 6 factorial over 6 minus 6 factorial, but 0 factorial is 1. And 6 factorial is 120. 6 times 5 is 30 times 4. So that's 720. Yeah, this is 720. So that's going to be the answer. They can interview or they can schedule the interviews in 720 different ways. So producers can schedule the interviews in 720 different ways. So mainly from the context, you will determine whether the order matters or it doesn't. Next one. On the same page, we're doing number 34. About selecting roommates. Annette has rented a summer house for next semester. She wants to select 4 roommates from a group of 6 friends. So all she wants is 4 different friends. Doesn't matter which she selected first or when she selected next. So this is going to involve combinations. So order is not important. She just wants to select 4 different friends from a set of 6, so that's going to be combinations of 6 people taken 4 at a time. The formula is 6 factorial over 4 factorial times 6 minus 4, which is 2 factorial. Then 6 factorial, you can do this with one click on your calculator. If you don't have the calculator with you, that's not a problem. This is 6 times 5 times 4 factorial. So that way we cancel the 4 factorial. And then 6 times 5 is 30. 2 factorial is 2 times 1 or 2. And that's it. So she can select 4 friends in 15 different ways. So Annette can select her friends in 15 different ways. And the next two, they look very similar, but one will involve combinations and another one will involve permutations. So I'm going to copy these two together. Number 39 and number 40. In number 39, 10 magazines are competing for 3 identical awards for excellence in journalism. No magazine can receive more than 1 award. And number 40, the awards are all different. So no magazine can receive more than 1 award. So these look very, very similar, but they are not. In number 39, if the awards are identical, the order doesn't matter. As long as they select 3 different magazines to give the awards, doesn't matter. I mean, which one they selected first, they look the same. So order is not important. And they can give the awards in combinations of 10 elements taken 3 at a time. So this is what? This is 10 factorial over 3 factorial, and 10 minus 3 is 7. 7 factorial. So this is 10, 9, 8, 7 factorial. Divided by 3 factorial, that is 6. And 7 factorial, whatever that is. We can cancel that. And then we can reduce some of these fractions, like for examples, 9 and 6, we can reduce this as 3 and 2. And then 10 and 2 as 5 and 1. We have at the end 5 times 3 times 8, which is 120. Okay, so it can happen in 100 different ways, 120 different ways. They just need to select 3 different magazines. Now, in number 40, the order matters because the awards are different. So you can select the same 3 magazines and give them different awards. And that's going to be a different situation. Let's say the awards are, okay, so number 40, let's suppose that these are the best of the year, most original, and most creative. And then you select 3 magazines. Let's say magazines 2, 4, and 8. So you give the awards in this way. But then You can change the order. You can do 4, then 2, then 8, and that's a different situation. Or you could do 8, 2, and 4, and that's a different situation. So in this case, the order matters. So order is important. And we are looking for the order of for the number of permutations of 10 objects taken 3 at a time. This is 10 factorial. And then 10 minus 3 is 7 factorial. 10 minus 3 is 7. So that's 7 factorial. So this is 10, 9, 8, 7 factorial over 7 factorial. And 10 times 9 times 8 is 720. Okay, so this can happen in 700 different ways. Okay, thank you for listening.